The main objectives we focused on during the design process was meeting the requirements given to us, them being structural, architectural, construction, sustainability, and financial requirements. It was also imperative that we ensure the stability and the safety of the structure by including safety measures and making justifiable assumptions during our calculation process.
The building will have 3 entrances, where 2 will be used by the public during large sporting events, located on the left and the bottom on the diagram, and an entrance on the right which will be exclusively used by the players during the Commonwealth Games. However, during Legacy Mode, this entrance will be open to anyone. As well as this, there will be 2 emergency exits as seen here at the top, to provide the spectators seated on the top side a nearby exit to access during an emergency. These will only open outwards in the direction of escape. Players entering through the players' entrance will be met immediately by 2 sets of changing rooms, one on the left for one team and the other on the right for the opposing team. This will be further split into male and female changing rooms in case they are playing back to back, and also for Legacy Mode. Each changing room is equipped with lockers, ample space for changing, wash basins, 7 showers, 3 toilets, as well as a shower and toilet for wheelchair users. There are 4 toilets, one in each corner of the stadium, so that the spectators are never too far from one. Each one has a disabled toilet, 6 female toilets, and a male toilet, which has 2 cubicles and 4 urinals. In our building, there are 1,960 temporary retractable seats and 2,068 permanent seats. This results in a gross capacity of 4,028 during large sporting events such as the Commonwealth Games, and in Legacy Mode, where the facilities will be open to the public, there will be 2,068 seats available. When the arena is in Legacy Mode and the temporary seats have been retracted, the activity area can accommodate for 3 netball or basketball courts, including the clear surrounding area that is required.
During an emergency, it is important that the arena's occupants have plenty of time to evacuate the building. To provide this, the structural timber members will have fireproof coating applied to decrease the burning rate and the spread of fire. To avoid bottlenecks in the arena, each section of seating has a unique egress path that they will take, so that large amounts of people will not be concentrated in one spot. This will help avoid injuries and blockages. As well as the 6 exits from the upper floor, they will be provided with 8 more emergency stairs that will help relieve pressure on the other exits, and will utilize exits found in the corner of the arena to maximize efficiency and subsequently the time available to evacuate. The wheelchair users seated on the upper floors, shown by the green arrow, will have priority during evacuation. They will be managed by the arena staff members so that they can quickly reach the closest lift, in this situation the yellow arrow.
In terms of the structure, our initial designs revolved around how the roof would be supported, having considered an arched version, but finally opting for a simpler truss system. We wanted our walls to be straight, to be able to accommodate the full interior requirements without leaving the side's premises, separated by columns and cross-braced on both directions to transport the load from the roof to the ground. Having decided that one of our top priorities should be safety and stability, for the shape of the arena we designed the structure shown here at the bottom right, making sure to keep an interesting look with curved edges and smooth roof height transitions.
When considering materials, we decided that all columns, beams and trusses will be made of laminated veneer lumber, also known as LVL. This is because it is a strong, dimensionally stable timber which can withstand great shear stress and is proven efficient in various large timber structures. All timber members are connected with steel nails. At points where 3 or more timber members connect, steel-plated connectors will be used, as shown in the bottom right picture. We chose to have a slab foundation for the stadium as it is a low-rise building. This means that using piles is more likely to be a waste of materials rather than increase the stability of the structure. The slab is made of precast concrete. This type of concrete is sustainable, has high compressive strength and provides insulation, making it very suitable. The facade of the building is made of compressed fiber cement, which provides the same amount of insulation as concrete but is much lighter, which decreases the load on the foundation and soil. Finally, the roof of the stadium is made of aluminium. It is a cheap, durable metal which can be easily bent to shape, and unlike steel, it does not form rust. This is the final design of the stadium. Windows made of laminated glass have been placed around the whole structure to provide natural light and make the building look more aesthetically pleasing.
Construction of an arena involves clever problem solving, considering the size of our members. For the trusses, these are to be brought to site in 3 different sections shown above, prefabricated and ready to be combined once placed. This allows for effective construction through programming, where one section can be placed whilst the previous one is yet to be completed. The sections shall be supported temporarily after being placed using large telescopic mobile cranes that will be able to freely move in and out of the building.
Our timber will be sourced from Donaldson Timber Engineering, where Curto and special laminated veneer lumber produced by Metsa Wood can be sourced. In specific, it will come from Chipping Norton, Oxfordshire, at 1 hour 20-minute drive from Birmingham. The concrete used in the stadium can be sourced from the Cemex Aston concrete plant, which is in the city at a 15-minute drive. To carry these and the rest of the construction materials to our site, a combination of vans and lorries will be used. However, some parts, especially large ones like the trusses, will have to be carried in long trucks, which can be difficult to operate within narrow roads, and that could lead to accidents with both other vehicles and pedestrians. For that reason, we decided to avoid the road north to the construction site, as it is too narrow and close to a car park, meaning potential pedestrians trying to cross to the road to get to their cars. Once there, the truck should arrive before the construction works start, so they can unload and go back to the road when there is enough space for them to do a full turn on site and leave. The vans and lorries should deliver moments before the building materials are required to avoid having them outside and unused. However, as they are smaller than the trucks, they can be parked for some time on site.
Finally, we use the dimension, density and volume of each material to calculate the material budget and embodied carbon of a structure. The cost of materials is approximately 1.2 million and embodied carbon rating of the structure is A. Thank you for watching.